Thoughts on DevOps on AWS by Noah Gift. Section 1, there is a collective realization amongst industry professionals that cloud computing enables new workflows. For example, cloud native solutions like serverless computing open new ways to architect solutions in an event-driven manner. Likewise, the underlying elastic capabilities of cloud computing enable virtualized storage, networking, and computing. DevOps, a blend of practices combining software development and operations best practices, is one ideal methodology to harness these new workflows. Section 2. This chapter's central focus is identifying the importance of DevOps to utilize cloud computing fully. It covers getting started on DevOps for AWS and principles supporting DevOps rooted in Japanese culture. Section 3, getting started with DevOps on AWS. An ideal way to get started with DevOps on AWS is with a definition of how AWS sees DevOps, the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. In practice, this means that AWS provides managed services that support a high-velocity workflow enabled by DevOps. Section 4, underneath the surface of DevOps is a definite historical trend of organizational best practices supporting the rise of DevOps. Let's discuss these concepts next. Section 5, what are the principles behind DevOps? At the heart of DevOps is the Japanese word Kaizen, meaning improvement or change for the better. In the Toyota Way, second edition, Jeffrey K. Liker mentions that post-World War II, Toyota developed a lean manufacturing system that incorporated this Kaizen philosophy. Ultimately, this philosophy led to Toyota being one of the leaders in automobile manufacturing quality. Section 6. One of the core principles of the Toyota production system is that assembly line workers will stop the moving production line to fix abnormalities. Another way to describe this process is Plan, Do, Check, Act, or PDCA cycle. First, a problem needs identification. Next, you try out a solution, analyze the results, implement the fix if it solves the problem, or repeat the entire PDCA process. Section 7, essentially, PDCA is the scientific method implemented as a manufacturing business practice. And according to Encyclopedia Britannica, the scientific method is a mathematical and experimental technique employed in the sciences. More specifically, it is the technique used in the construction and testing of a scientific hypothesis. Section 8, related to both Kaizen and the scientific method, is the 5 whys technique in debugging the root cause of a problem. This technique works in the following manner. First, you identify a problem. Next, you ask why. When you receive an answer, you ask why again, until ultimately, by the 5th time, you get to the root cause of the issue and have a solution to fix it. The origin of 5 whys has a historical lineage to the Toyota production system, and it works well with the concept of continuously improving a system. Section 9, children are intuitively very good at the 5 whys technique, which is why they ask simple, practical questions such as, why is the sky blue? Followed by the next question. An incredible way to get in the right mind frame for using the 5 whys technique is to ask questions the way a child would ask them. Section 10, notice that the series of questions eventually leads to a reasonably straightforward fix. Configure machines differently, use EBS storage, enable a swap partition, and configure the memory constraints of the Java process to match the resources on the server. Section 11, as you can see, DevOps isn't something invented overnight. DevOps derives from centuries of improvements in critical thinking, from the scientific method centuries ago to, more recently, Kaizen and the Japanese automobile industry. At the heart of DevOps is the ancient concept of the scientific method, that is, asking why. The Japanese automobile industry refined this into the methodology of asking why, coupled with continuous improvement in manufacturing. DevOps is the further refinement of this continuous improvement manufacturing methodology in the software engineering domain, which is now ideally suited to cloud native development. Now that we know where DevOps came from, let's discuss the best practices on the AWS platform. Section 12, AWS DevOps best practices. And an ideal place to start with AWS best practices is the introduction to DevOps on AWS AWS white paper. Inside, there are 6 best practices listed. Section 13, continuous integration, CI. The heart and soul of DevOps is a continuous integration system. Developers periodically merge changes into a central source control repository where automated tests run on the code. A developer in one environment, perhaps a laptop or Cloud9 workspace, pushes changes to the source code repository. It triggers the build, tests the code, and allows it to merge. Later, a second developer pulls these improvements into their checkout in a new local environment. Note the tie-in to the concept of Kaizen here, or continuous improvement. Since each time the build server test changes, the system can improve the quality of the source code. Section 14, continuous delivery, CD. Continuous delivery builds on the concepts of continuous integration by automatically testing software pushed into the repository and preparing the software for release to any number of environments. In a CD workflow, containers are a complementary aspect of the deployment since they work side by side with the deployment of the code and infrastructure. Kaizen again plays a role in deploying improvements automatically. Each commit to the source code repository adds improvements to the system, and since changes are easy to make, it encourages frequent minor enhancements. Section 15, Infrastructure as Code, IAC. IAC is a software development best practice that describes treating the provisioning and management of infrastructure as code checked into a repository. The IAC workflow can do many valuable actions beyond initially creating the infrastructure. Some of the use cases of IAC include making idempotent changes and cleaning up experiments efficiently by deleting the entire stack. Section 16. Idempotent is a word frequently used with DevOps because it is essential to be able to do the same action repeatedly and always have the same state. An outstanding example of an idempotent deployment process is IAC that creates an S3 bucket with read-only permissions. No matter how often this code runs, the result will be the same, an S3 bucket with read-only permissions. Section 17. The concept of idempotent actions is essential in DevOps because an automated agile workflow depends on automation actions that have the same effect no matter how often they run. A fantastic example of the mathematical foundations of idempotency is multiplying a series of numbers by 0. The result is always 0, no matter what number you multiply by 0. Section 18, monitoring and logging. Data science for software systems is a unique way to think about monitoring and logging. It is essential to use data about the infrastructure and deployed application to determine what actions are necessary to maintain a deployed application. Servers send system and application level logging, metrics, and data from monitoring agents to AWS CloudWatch, where the data is centralized and distributed to dashboards, alerts, search, and automated insights. Section 19, communication and collaboration. DevOps is a behavior, not a specific task to check off a list. As a result, when teams work together to implement DevOps practices through communication and collaboration, an optimal outcome results. And communication embeds in every step of the DevOps lifecycle, from code itself and the conversation around it to the alerts from production systems that emit into a chat channel. Note also the possible human interactions on pull requests, pushing to production, and monitoring the application in production. Section 20, security. Security needs integration at every level of building a software system. Additionally, the continuous integration and delivery systems need strict access control governance as they deliver software to production. Notice multiple layers of security in an adequately architected system on the AWS cloud. This system includes firewall rules layered into a VPC to prevent unauthorized network access and policy control that leverages the principle of least privilege to secure the system. Encryption for data in transit and rest hardens the environment against leaked data. Finally, auditing all security events via AWS CloudTrail and two-factor authentication for access to the AWS console adds even more protection. Section 21, these core DevOps principles are essential to consider when architecting a modern solution on the AWS cloud. Let's dive deeper into specific CI/CD, continuous integration, and continuous delivery services on the AWS platform. Final section. At the heart of modern DevOps is an embrace of the cloud. Cloud computing enables even deeper coupling of automation, testing, and speed of deployment. One example of this integration is infrastructure as code, or IAC, which is the perfect vehicle for DevOps workflows. DevOps also enables optimal human interaction at key points of the lifecycle of software engineering, from code reviews via pull requests to working with a release manager on a production software release to finally monitoring the production system.